All right, welcome back everybody. We are now looking at the board for project 9 of our Arduino project kit. And this one is the motorized pinwheel. And as we were looking at in the last video for the code is pretty straightforward, right? We have our pin 9 going into our transistor and our pin 2 reading from our button. And that's pretty much about it, right? So the board itself, I'm going to save the transistor part for last. The board itself, the power is coming into our button, right? From there, it's hitting, for the output from our button, it's hitting the transistor, and that's coming into ground. Now, on the same line, it hits our pin 2 for our data input, and this is what we read to determine whether or not someone's pressing the button. You can see that we hit the resistor, and then we hit the pin, and then we have the power go through the resistor to ground, right? Just kind of protecting our circuit here. Now, the other part I want to point out before we get involved with the transistor is you'll notice here that I have my common ground between my 5 volt and my 9 volt. This is very, very important to always have. When you have circuitry that has variations of power, again, 5 volt from the Arduino board, 9 volt from our battery up here, right? So there, our battery is giving us 9 volts. This is giving us 5 volts. It's critical to have a common ground, okay? Now, you'll notice here on our motor, we have a positive and a negative, right? Power and ground, just like we have with everything else. You might not be able to see the colors on the wires just there, but that should be a little bit more clear, right? So you got the red and the black for the power and the ground. So inside of this motor is also a bunch of circuitry that must be complete, right? So if we were to just take this ground completely out of the circuit, giving this motor any kind of power on the positive wouldn't matter at all, because the circuit's not complete. And as a matter of fact, that's exactly what's happening right now. If we take a look on this outer track, we see this is the positive, and we have the positive of the motor plugged in. Our 9 volt is always giving out power. It's not like there's an off switch in here. So we actually have power coming into the motor right now. But we don't have anything spinning because, well, the circuit's not complete. For all intents and purposes, right now, this ground is unplugged. If I took this out of the breadboard, the behavior of this circuit would be identical. If we were to take this ground and put it into the neutral right here, or the ground, this thing would start spinning because it's getting power and the circuit would be complete. So what we do when we set this 9 pin to high, right, once the button is pressed, we get the signal that the button is high. And when we have this button pressed, we send a signal out on our 9 pin. We power on, right? We do the digital write to high, and we bring that into the very top leg right here on the transistor, okay? And I'm going to take this transistor out, and I'll come back to this in just 1 second because I'm going to unplug the power as well. All right, so I went ahead and I turned off the circuit, so I've taken the batteries out just so we're not running anything through an incomplete circuit. But what I want to show is when we set the 9 volt or the 9 pin to high, it's going to come in, it's going to hit this very top leg, right? And this is the gate we were talking about. And what happens when it hits the gate right here, it allows this red pin, this red wire, which is connected to the middle pin, which is also connected to the ground right here of the motor, and it allows power to be complete. It actually will draw this in and pull that power into the transistor. So therefore now you would have a completed circuit, right? Then you'd have power going in, and the power coming out is actually going to a ground. And you might ask, how is it going to the ground? Well, this ground is coming to just a regular input. This is not a ground connection here at all. This ground is going to this middle pin. What happens is when you turn the transistor on by setting the 9-pin to high, it allows electrical power to come in and flow back out, and that's where we're connected up to our ground. So when we turn this off, when we set our 9-pin to low, this doesn't allow any power to come in anymore, blocks it off, which is the equivalent of unplugging this entirely from our breadboard. So when we set this to high, we basically turn on the transistor. That allows the ground to push power into this transistor, even though it's 9 volt and we're going out to a 5 volt. It allows this power to get pushed out, come into this middle pin, and then come back out on this third pin to our ground. So by turning this on, it allows the circuitry in the motor to complete, and that's where we get the rotation of the motor. Now, the only other thing to really kind of point out is this diode, which I'm going to come back to in just a moment after I plug the board back up. All right, so got the board plugged back up, have the power coming in, and what I want to take a look at really quick is this diode. And what this diode is doing, if you'll notice, the stripe over here allows the power to go into our power voltage, right? So the power from the 9 volt is coming on this outer track, and we also have our diode going to this outer track, right? It would almost seem like this is a ground, so we'd want our diode to go into the ground, right? To kind of complete everything out. But really what's happening here is when the circuit is allowed to flow in, right? We've got 9 volts and we're going into 5 volts. Now the transistor helps us out, but before we even hit the transistor, we're likely to bleed over potentially bleed out some power, right? And this diode allows a one-way electrical flow that we can bring back out onto the power line. It's still positive. It doesn't have to be, it doesn't have to go to ground. So we allow that circuit to flow, and it's one way. So when we have this, there is, even though there's power coming in right now on the 9 volt on this outer track, there is no power coming back into the ground. This is one way. So it only allows electricity to flow in one direction. So there's nothing coming in right now, and any bleed over is just going to come back out to the power, help us power up the board a little bit. Right, we already lost some power, so it's not like we're going to overpower anything with this. It doesn't cause a loop in the circuit or anything else for a short circuit. So again, it's just one-way power. Now, I will say that my kit did not come with the diode. I don't know why. Hopefully yours did. I had to order mine separately, so just keep that in mind. There might be a little hiccup in your Project 9 if that's the case. But they're pretty easy to find online and order them. Got here in like a day. So anyways, that's the whole project, right? It really is about understanding this transistor. And so now I'm just going to go ahead and pick up the motor, and I'm going to give it some power. At least I think I'm going to give it some power. All right, so there we go. Hopefully you can see that. If nothing else, on a hot day, it'll make a nice little fan. So anyways, that's it. That's the project. Again, understanding transistors will just, take a little bit of little extra effort, but once you understand them, they're obviously great for when we do talk about motors. They typically require more power. It takes a lot of power to move stuff. And then boards, they typically need a whole lot of resistors to protect them and fragile circuitry internal. So there's, you know, the powerful needs a lot, and the gentle kind of needs a little bit less power to kind of move through. So anyways, definitely take a look a little bit more at transistors. I hope this one helped you out. I know it can be a little bit confusing when you first start taking a look at these things, but it's time well spent, especially if you're looking to get into electronics and embedded circuits. So anyways, that's Project 9, and we look forward to seeing you back here in the next video when we move into Project 10. Take care, everybody.